Alright, so this is the 7th period video. We'll do the multiples of 4. This is the easiest one to keep up with. So I'll put the multiples of 4 on video, and then after that I'll take whatever questions, whatever other questions you have. So let's start with number 4. 10 absolute value 7x minus 8 minus 9 equals 71. Okay, so absolute value equations. That means I'm probably going to get the absolute value thing by itself first. And then to handle the absolute values when we split them up. And maybe we have to check answers, maybe we don't. Do you know if we have to check them on this one? Do you remember what the...
I think you do.
As long as the x is in the absolute value.
As long as there's, I would phrase that a little bit differently. As long as the only x's are in the absolute value, then you don't have to check. Phrase that differently. If there's an x outside of the absolute value bars, like number 5, then you would have to check. So number 5, you would have to check. Number 4, we don't have to check. I mean, maybe it's a good idea to make sure we did the math right, but it's not a required check. Okay, so add 9 to both sides, we get 80. Divide by 10. Absolute value of 7x minus 8 is 8. And now we do the split up thing. So equals 8 equals negative 8. 7x minus 8 equals 8. 7x minus 8 equals negative 8. So 16/7 and 0. And I don't have to check those. We are okay to not check those. This might be one where, as you're working the test, you put a star next to it because you're like, I don't think I have to check them, but I'd sure like to know if I got those right. So at the end of the test, you come back, and if you got 5 or 10 minutes left in class, then you plug them in and make sure that they work. But you don't have to for those. Plugging in 0 would be easy. That might be worth doing. 10 times 8 is 80. 80 minus 9 is 71. So 0 definitely works. The other one would take a little bit more effort. As opposed to, say, number 8, where there is a variable outside of the absolute value bars, so I will definitely have to check once we get answers for this one. Maybe they both work, maybe neither works, maybe 1 and 1, but we got to check. So 2x plus 3 equals x plus 5, and 2x plus 3 equals negative x minus 5. So x equals 2, that's an easy one. And on the other side, 3x equals negative 8. Negative 8 thirds. That one's a little bit more annoying, but again, this one I have to check. So let's plug in 2. 2 times 2 plus 3 equals 2 plus 5. 4 plus 3 is 7. 2 plus 5 is 7. So yes, x equals 2 is good. Negative 8 thirds. 2 times negative 8 thirds plus 3, absolute value of all that, equals negative 8 thirds plus 5. Okay, here's some of the algebra review that we're not explicitly reviewing, but that is on the test. Multiplying fractions. What's 2 times negative 8 thirds? Negative 16 thirds. Don't need a common denominator. Please don't multiply the 2 to the top and the bottom. Just negative 16 thirds. Plus 3, oops, speaking of common denominators, 9 thirds would be the same thing as 3. I'd multiply the top and bottom by 3. Negative 16 plus 9 is negative 7, but the absolute value would turn it into positive 7 thirds. And more common denominators. So 3 over 3. Negative 8 plus 15 all over 3. That would be 7/3 as well. So this one works. People will miss this problem right in here. They'll see negative 16/3 plus 9/3 and think, aha, that's negative 7/3. It doesn't work. But it's in the absolute value bars, so it does work. So please be careful when you're checking. Remember, this one was a required check because of that X that was not in the absolute value bars. Okay, so that's two good problems. One we had to check, and one we didn't have to check. Number 12. Ooh, negatives. Ooh, jeez.
Do we have to check the inequalities?
You don't have to check the inequalities. What do you want to do first on number 12?
Add 6.
Add 6. I'm worried about this negative, but I don't get worried about it until after I add the 6 and then see what's happening. So add 6, which would be the same thing as adding 66/11ths. So 6/11ths in is less than negative, let's see, negative 83 plus 66 would be negative something, negative 17. Uh-oh.
Was it no solution?
Why is it no solution, Moises? You're right.
Because it's greater than the absolute value. The
Less
negative.
than negative.
Okay, you said it kind of backwards. You said it right. The negative is bigger than absolute value. That doesn't work. Maybe it's better to read it left to right. Absolute value is always 0 or positive. That's never going to be less than a negative something. So this is no solution. My hope is that you catch it right there and don't go any further and realize that it's no solution. The trouble is, some people are so procedural oriented rather than concept oriented. It's like if you understand the concept, you catch it there. If you're just locked into, hey, every time I get one of these problems, I split it into 2 and I go from there, that will work, and I want to show you how it works. But again, with the reminder that I'd rather you not have to do this. 6/11 in is less than negative 17/11ths. Less than means it's an and problem. 6/11 in is greater than positive 17/11. Change both sides. Multiply through by 11, that's easy. So n is less than negative 17 over 6. And, meaning I'm looking for the overlap. 6n greater than 17. N is greater than 17 over 6. So let's draw a picture and see what it looks like. So less than negative 17/6. Greater than positive 17/6. And I want the overlap. Where do they overlap? Nowhere. So no solution. So if you're careful, you can get to no solution using the same procedure every time. It would just be a whole lot better if you recognize right away what was going on and not have to go through that. Trip?
Do you have to do like all that on the test, or can you just say no solution?
No, my preference, my hope, is that you recognize this right here and you're like, wait a minute, that doesn't work. No solution, I'm done. This could be another one where you write no solution and then you're like, you know what, I think I want to check and verify that later, but not until you finish the test. Would you kind of spin your wheels down here? Brenda?
For the and the or, anything with like the equal, like less than or equal to or greater than or equal to, that one's or, right? And then
No, what makes it the and or is greater and less than. And then again, be careful. Don't use that until you've got the absolute value thing by itself.
okay.
Because things could switch around until you get to that spot. Good questions. Anything else on 12? right, number 16. Let's divide by 3 first. So absolute value of negative 3m is greater than negative 30. Got another negative there. Absolute value is greater than the negative 30. Yes, that's the correct response. Yes, that is true. So for what values of m is it true? All of them. That's right. Because you're going to get 0 or positive. That's always greater than negative 30. So interval notation would be negative infinity to infinity. If you wanted to, you could turn this into an OR problem. Again, I'm drawing the line because we should be done. Negative 3m greater than negative 30, or negative 3m less than positive 30. And you end up, so you're not looking for the overlap, you're looking for anywhere that's shaded. It ends up looking like this. And so this one, people will mess up the procedure because they'll be like, oh, it's negative 10 to 10. Like, nope, it's an OR problem, so anything that's shaded works, and it's all shaded. So, again, you can get there the procedure way. It's just probably better, quicker, safer, easier even, to get there the concept way when you recognize what's going on. All right, last one for the video, number 20. Add 6. I think we finally got a regular looking problem here. Divide by 6. Yeah, so we hit the 2 weird ones, and now we get a kind of a normal one. Brenda, is this an AND problem or an OR problem? An OR problem. So 7n. Yes, it's greater than or equal to. But that'll just mean the closed circle in the bracket when we get there.
Okay.
The equal to part. So 7n is greater than or equal to 0. N is greater than or equal to 0. Or 7n less than negative 12. N less than or equal to negative 12 sevenths. So bigger than 0, but or less than negative 12 sevenths. And we don't want the overlap, we just want anything that's shaded. So negative infinity to negative 12 sevenths, bracket, and then 0 to infinity. So finally a normal type of problem.
Are we going to have to write interval notation for the test too?
Definitely.
Okay.
Definitely we'll have to write interval notation for the test. I'm going to get it on video in case someone's not here and watches later. Number 21, you don't have to do those extra problems there. I mean, good practice, but not required. Okay, that ends the 7th period multiples of 4 video. Again, if you want other problems, then you go find the video that has those problems on it.